This tutorial was brought to you thanks to the supporters on the screen. Check out TAPgiles.com to find more Dreams resources, donate to support my work, or engage my services to get private instruction or help on a project one-on-one. Right, so if I make this into a chip, and I'll display the position. Okay, so now we can move that around and we know the scene's position of that. Yeah, so we get these X, Y, and Z for the position out from a fat wire, which is why it looks like all rainbow and braided up and stuff. But also we can just put it into something and get a different value out. Yeah, so that's giving a different value from these numbers, and that is because if I turn on the floor, and then we can see how this interacts with where this is in relation to the floor. So if we put it near the center of the scene, then the X, Y, and Z position, the actual location of the tag, is close to 0, and so is this. Now if I move this, if I actually put this on the grid, now it's perfectly 0 because it's right in the center. If we move it up a little bit, you can see the Y is matching the Y, or this special value is matching the Y. And if I put it just along the x-axis, you get this negative 1.5 and this is 1.5. This is because this default value, that I'll call it, that you get by just plugging it into something, is actually the magnitude of this vector, which means how far away is it from 0. So when it's just going up by 1.5, then it's 1.5 away from 0. But it doesn't matter where you put it, you always get the magnitude. So if I did this without using a tag, we can like mess with the values and stuff. So this works with the two numbers, which will be like the two sides of a triangle, and it will be the hypotenuse of it. And 3 numbers and 4 numbers and 8 numbers, it finds the magnitude of those vectors. Apparently that's just how it works math-wise. And left and right stick it works for, because that's just a 2D number. Yeah, that's about it. So if I have this stick, if I just get a controller sensor, and I'll put it onto remote controllable, and then pin this to the screen, and I'll use the right stick local and put that in there, then we're getting 2 values, and if I push on the right stick, it gives me those values. And what will this give me? Well, it's how far away the stick is from 0, which is the center. So it has like a maximum of 1, but it's all just like how far the player is pushing the stick in whatever direction they're pushing in, which is pretty cool. So it's a very easy shortcut to use. Now if you want to use it with a calculator or something, say I wanted to multiply it by 10 and then wire that in there, the calculator works on each individual value. So it has this x and y, and then it multiplies x by 10 and spits it out, and it multiplies y by 10 and spits it out, and then you get this fat wire out the other side. But if you want to make sure you're only getting that default value of the magnitude, then you can use a combiner and wire it into there, and just put it into the positive and leave it on the default setting, which is signal. And now it just extracts basically that value. That's a very useful shortcut in some cases, like if you want to know if the player is how far they're pushing at the stick affects the character's movement, things like that. We also have sensors which give you all sorts of outputs. One is the movement sensor, and if we just link that up with this sensor movement onto the box, now even though it's not moving, it still gives useful outputs. So it has like acceleration and velocity, which don't really make any sense because it's not moving anywhere. But it also has these things down here: X direction, Y direction, Z direction. So if I plug X into the splitter, then we can read out what that's saying. These different values actually correspond to X, Y, and Z. So X, for the X direction, X is 1 and Y is 0 and Z is 0 as well. as you'd expect, and similar for the Y and the Z directions. So we're currently reading out X, and even if you rotate this, nothing really changes with these outputs. But if you put it onto local space mode, then if we keep that open, you can see that's the X direction that we're talking about. If you go to that, now these are changing. Now these are giving the direction from that dot pointing in the direction of that X relative to the object. And you can actually change these by rotating these axes like that, and now X is going to point in that direction, and no matter what orientation this has, this direction is what direction is that X thing pointing at within the scene. So you can have that wired into other things like a emitter or something like that, where you tell it the direction to throw something in or something. Or you can use it as a configuration thing. So you have a contraption. It says what direction it's going to throw the player in or something when the player gets close to something. And you can just rotate that and say it's going to point in that direction. So with a better example, you could use a different shape, such as a cone, like that, and wire it to that instead. And let's just rotate that on the grid. So now X is going to be our forwards along the cone direction. So now we can say, I want the character to be flung over that direction, and it will be, because we can use that direction with other things. So for example, I'll just make a quick test thing. So we have an emitter, and we could set the direction it's flinging stuff in with this scene space direction. So we could wire that into there, and now it's flinging it in that direction, and we could move it over there, and now it's flinging in that direction. And this could be attached to another object, and which is moving around or something, and then it would affect the emitter. And there's lots of different ways you can use it, basically. And that's from the movement sensor. Thanks for watching. I hope you learned something new. Go to patreon.com/TAPgiles to get 5 hours of tutorials early for $3. Here's a preview of what you can learn if you choose to become a supporter.